life could have emerged just 350 million years after the universe began. Recent discoveries by the James Webb Space Telescope have turned our understanding upside down. 350 million years after the Big Bang, the universe was already hosting the key ingredient for life as we know it: carbon. Carbon isn't just a random element in the periodic table. It's the backbone of all known life forms. When scientists detected carbon in a galaxy just 350 million years post-Big Bang, it was a game changer. This finding means the essential ingredients for life were ready to go much earlier than we ever imagined. The James Webb Space Telescope played a crucial role in this discovery, revealing chemical fingerprints from the early universe. So, the Big Bang happened around 13.8 billion years ago, creating a universe that was incredibly hot and dense. Imagine a cosmic explosion that spread matter and energy in all directions. In those first moments, the universe was a chaotic soup of particles. As it expanded and cooled, protons and neutrons began to form simple nuclei, primarily hydrogen and helium. This period is known as the Big Bang nucleosynthesis. But it wasn't just hydrogen and helium. Heavier elements like carbon, oxygen, and nitrogen, essential for life, were forged in the hearts of the first stars known as Population 3 stars. These stars were massive. They lived fast and died young, exploding as supernovae and scattering these elements across the universe. This process enriched the surrounding gas clouds, which later formed new generations of stars and planets. What's groundbreaking about Webb's discovery is that it detected these elements in a galaxy just 350 million years after the Big Bang, indicating that this cycle of star birth and death happened much faster than we thought. Here's the exciting part. These heavy elements scattered across the universe are the building blocks of life. Carbon, for example, is essential for forming complex molecules like DNA and proteins. Oxygen is crucial for cellular respiration. The early presence of these elements means the basic ingredients for life were present almost as soon as the first stars appeared. This rapid enrichment challenges our previous timeline of when life could have started. If these elements were available so early, it's possible that life, or at least the precursors to life, could have begun forming shortly thereafter. Additionally, Webb's detection of other essential elements like oxygen and neon in these early galaxies supports the idea that the universe was chemically enriched rapidly after the first stars went supernova. But let's talk about the hypothetical early life forms that could have existed. Traditional life as we know it relies on carbon, water, and a range of other elements to form complex organic molecules. But could life have existed under radically different conditions in the early universe? Some scientists speculate about the possibility of exotic life forms. For instance, what if life wasn't based on carbon? Silicon, another abundant element, could theoretically form complex molecules similar to carbon. There's even the idea of life forms using methane as a solvent instead of water. These ideas might sound like science fiction, but they challenge us to think about life's potential diversity in the universe. But here's where it gets even more intriguing. Life might not need traditional chemistry at all. Some physicists propose that in the extremely high-energy environment of the early universe, exotic structures like cosmic strings or folds in space-time could have stored information and undergone Darwinian evolution. These structures could have been short-lived by our standards, existing for mere seconds. But in those brief moments, they could have experienced a lifetime of evolution and complexity. Moreover, there's the fascinating concept of dark life. We know that dark matter and dark energy make up about 95% of the universe's total energy content, yet we know almost nothing about them. Could there be life forms that exist within this mysterious dark sector, interacting through unknown forces? This is highly speculative, but it's a reminder of how much we still have to learn about the universe. Now, what do these findings mean for our search for life beyond Earth? If life could have started so early on Earth-like planets or moons, It might also have begun on other celestial bodies with similar conditions. This means that our search for extraterrestrial life doesn't just focus on planets in the so-called Goldilocks zone, the region around a star where conditions are just right for liquid water to exist. We now have to consider the possibility of life in environments we previously thought were too extreme or too young to support it. For instance, moons like Europa and Enceladus, with their subsurface oceans, could host life forms that evolved independently of Earth. The discovery of carbon and other elements in ancient galaxies suggests that life could potentially exist in a variety of environments, using different biochemical pathways. Moreover, this research broadens our perspective on what constitutes a habitable zone. If life can adapt to a range of conditions, then the number of places we need to investigate increases dramatically. So not only might life be more widespread than we thought, but it could also be incredibly diverse, existing in forms and places we have yet to imagine. This pushes us to refine our search methods and expand our criteria for what constitutes a potential habitat for life. Don't forget to watch the video on the right and subscribe. Thanks for being part of Cosmoknowledge.